want to solve 18, right?
Yeah.
Okay, sure. Let's try 18 together. How many squares, including high tilted ones, can be built with vertices of the green? Okay. And we should see that. Oh, this one is so much easier. Let me tell you. It says, so when we see a problem like this, I told you the most useful idea is what?
Small example.
Exactly. So try to use horizontal. It says we should also consider these things. So use a small example, and first a small example is what that you should check.
1.
1. Check N1 and N2. See for N1 and N2. The answer is what? Okay.
Okay.
Try.
Oh, okay.
You should consider the things like that instead of only considering these things. Okay. So for N1, the answer is what? Can you tell me for N1 the answer is what?
0.
Why 0? This one is a square.
Because it's 1 by 1. It's just 1 point. It's 1 vertices.
So
One
look, it
vertex.
says including tilted ones. Here we don't have that, but this is a square, right?
Yeah, but it's just 1 by 1 vertex.
What do you mean 1 by 1 vertex? 2 by 2 vertices.
Yeah, but this n by n point.
Sorry. This one is N2, N2. N1 is this one that we don't have anything, right?
Yeah.
Yes, thanks. Okay, for this one will be N3. For N3, the answer is what?
1 through 5.
1, 2, 3, 4, 5, 6.
How 6?
Understood why it is 6?
Yeah.
Look, 4, let me tell you. 4 1 by 1s, okay?
Yeah.
2 by 2 will be 1. Also, this one we have, it's 1, so it will be 6. Understood?
Oh.
Okay, so try to check, for example, N4 and 5, okay? And try to find a way to generalize it, okay?
Okay.
So we got 9 of those. Total ones 1, 2, 3, 4. And those ones aren't vortexes. So, first of all, Interesting. Okay, I think I have found something.
Okay, so your answer is what for N4?
Is it n minus 1 squared plus n minus 2 squared plus uh dot dot plus 1 plus n minus 2?
For general N, you are saying?
Yeah,
Okay. For general N, at first tell me some of them are horizontal, vertical, some of them tilted one, right?
yeah.
And tilted one maybe similar to this one. Let me draw 4 by 4 to tell you one of them is what. For example, maybe it is similar to, let me tell you, this one, this one, this one, this one. Have you considered also these tilted squares?
No, I haven't.
Okay, so let me tell you first something. When it is horizontal and vertical, the sides, it will be what this part is easier.
Pardon?
I said, do you agree we have two types of squares? Tilted ones and the ones that are parallel to xy axis, like this, right?
Yeah.
So these squares are easy to calculate. Can you tell me they are what in terms of n?
N minus 1 squared plus n minus 2 squared plus dot plus 1.
Plus n squared. Because again the grid, okay, the grid is n. I'm considering the length is n. Yes, 1 squared plus 2 squared to n minus 1 squared, right?
Yeah.
So, and the formula, memorize these two formulas, okay? They are useful. Here it says they are what, but in general you should memorize because in some problems we don't have them. So 1 squared to n minus 1 squared is what?
N times n plus 1 times 2n plus 1 all over 6.
No, careless mistake.
Oh, I didn't put the minus 1 in today. Yeah.
It is what?
N minus 1 times n times 2n minus 1 over 6.
Yes. Okay, so now focus on this one. Okay, so for this one, try to check, for example, for N4, how many? For N3, we have only one from this type, right?
Yeah.
For N4, see how many of them do we have for N5 and try to generalize that, okay?
Okay.
Well, I assume it's got to do something with k cubed, so
1 hint or wanna keep trying?
Could I get a hint, please?
Okay, sure. So for 4, the answer is what?
6.
Let's check. For 4, let's move it here. Okay. Let's copy this part. Okay, so here, for example, we can consider this part, right? For this type, how many? You said we have 6 in total in this part
Yeah,
for total ones. Okay, so for this type, how many squares are
4.
there? 3, 4, yes. Now let's consider
Yeah, but that's n equals 5.
here n is 4. 1, 2, 3, 4. Agreed?
Oh, right. Yes, 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 yes. Sorry.
No
Yeah.
problem.
Oh, yeah.
In all parts, I had careless mistake in this part you had. So n is
Yeah.
4, and we have this. Now, for example, another part is this one, right?
Yeah. And that
So,
has 2. That you can do the other middle one.
yes, this one,
Yeah.
right? 2, we don't have. Now we want to see how can we make sure that we don't have any other good case.
Well, what I did was divide it up into smaller squares. So the smallest one you can have tilted with is a 3 by 3 vertices wise, and though you can only have one in those. And then I tried. There's no other way to do tilted ways in 4 by 4 because all the other vertices are taken. You can't use any other vertices. There are none to use.
Yes, we can say that. And let's consider something. This, for example, this square. Do you agree we had also this square in 3 by 3?
Yeah,
This one was new one, right? So somehow like induction, do you agree we can say, okay, because it is a 3 by 3, because we have 4 3 by 3s, then we have 4 of this type, right? Because
yeah,
you can move this. So we should see each tilted one is in what square, okay?
yeah,
So let's see. Suppose, for example, we have n endpoints. 1, 2, n by n. Or let's consider 4, 5, 3, 4, 5. 1, 2, let me copy. Control C, Control V, for example, this one, 4, and 5, okay? Now I don't want, for example, to calculate this one, okay? Because we know we had this and also this one, right?
yeah,
We had this one. I want to calculate the squares that need 5 by 5, okay? I want to see how many of those types are there, okay?
okay.
So try to see how many of those types are there.
So you take a 3 by 3 frame and then you move it.
That we can say, for example, it is in 3 by 3. Only it should be in 5 by 5. So look, this triangle, do you agree is only you need 4 by 4 for this square?
Yeah.
For this
Oh, you
square, You need 3 by 3. I want to find the tilted ones that needs 5 by 5. Okay.
Okay, so there are 3 of them.
Why?
Because you can only make them using the 3 points in the middle.
Okay, let's check. I should use, for example, this side, right? This side. Agreed.
Yeah,
And I should connect one from here to here, right?
yeah,
Do you agree if you can connect this one to this one, then it will be this, right?
yeah,
If we connect this one to this one, it will be this, right?
yeah,
If we connect, for example, this one to this one, it's not good because it will be outside, right?
yeah,
So this one to this one is good, right?
yes.
Do we have any other good cases? For example, if this one to this one is good or not?
It's good.
Yes.
And then you got one more with the bottom one.
So one of them is this one. One of them, this one is also good, right?
Yeah,
And this one is also good, right?
yeah,
We cannot connect any other thing, right?
yeah.
So
So
how many?
n minus 2.
In this case, for 1 to 5, it is 1 to 5. How many triangles like this are there?
Well, 3 squares.
3. Now I want to see that in n by n, so this one was, this one was 1, right? No. Let me tell you. This one in 3 by 3, if we determine it for 3 by 3, we have only 1 from this, right? Tilted 1. Agreed?
Yeah,
So up to this part, let me write it with what color? With, for example, orange one. So this one is 1, right? In 3 by 3, we have 1 from this type.
yeah,
From this one, we have 2 in 4 by 4, right? In 5 by 5, we have 3 of this type, right?
yeah.
So can you guess that in n by n, we have how many of these types?
n minus 2.
Yes, it seems that this one is correct. So 1, 2. Do you agree if you don't want to use a small example, it will be so much hard to find these results?
Yeah,
So that's the reason a small example is so much powerful. So we find the idea and then we try to prove this. So now you should prove why. For example, if you want to consider different cases of these, for example, which point to which point, why there are exactly n minus 2 good points, n minus 2 good pairs, okay, to connect.
yeah.
Prove this one and then solve the problem. I go and come back in 2 minutes, okay?
Okay.
N minus 2. Oh, we're gonna add up. 1 to n. K minus 2. Just make 3, 2, 1. That's the first question.
I'm back. One hint or wanna keep trying?
K equals 2 to n.
K minus 2. It's correct, but let me tell you something. K minus 2, K2 to n, right?
Yeah.
For tilted ones, right?
Yeah.
But do you agree, for example, for 3 it was 1, but because you can move it, you can create 4. In, for example, 4 by 4, right? Understood?
Yeah, nice.
So you should multiply K minus 2 by something, right? So
By n.
by n, no.
Oh. Oh, wait. It was 4. You.
Move around. How many is that? 1, 2, 3. 9 times. Oh, it should be n minus k all squared.
N minus K all squared y. For example, look, for this one, we know 3 by 3 has one tilted one. In N4, it is 4. You say N minus K whole square. So, with the things you said, does it satisfy? So here, look, N is 4, K is 3. By your solution, it will be 1 squared, right?
Yeah.
But do you agree here it's not 1 squared, it's 2 squared, right? Because we have 4 of this, right?
Um. Yeah. Okay. So wouldn't. Okay. So just add plus 1.
Exactly. Because in each N by N, we have N minus K plus 1 squared, right?
Yeah.
Okay, now try to calculate this one, okay?
Okay.
How would I solve this? It's a sigma. It's not.
Want int?
Yes, please.
Okay, sure. So for this one, k minus 2 times n minus k plus 1 squared, right?
Yeah.
So, we can say one thing. Do you agree for horizontals and this, it was sigma k from 1 to n? We said 1 squared to n minus 1 squared, right?
Yeah. There's case squared.
We can say n minus k plus 1 squared from k2 to n. Do you agree it will be same? Because if you want to write like this, if k is 2, it will be n minus 1 squared. If k is 3, it will be n minus 2 squared. If k is n, it will be 1 squared. So do you agree it will be this?
Yeah.
Now, if you add these two things, and we can factor k equals 2 to n, it will be what?
Yeah. Minus k minus 2 times
Yeah, so factor from common term, if you add these two things, it will be what?
n minus 2 plus 1 squared times k minus 1.
Exactly. And do you agree we can say it is, we have two k minus 1s in this problem, right?
No.
Agreed?
K minus. Why would there be 2 k minus 1?
Because here we have k minus 1, here also we have k minus 1, right?
Isn't that minus k plus 1?
Yes, it is n minus k minus 1, right?
Oh, you're right. Okay, yeah.
Okay, so n squared, we can multiply with this. 2n times this plus this. Okay, so do you agree it will be sigma n squared times k minus 1 plus k minus 1 squared times this k minus 1 cubed minus 2n k minus 1 squared. Agreed? Or want me to explain?
Want to see what we did there.
Okay, so let me tell you. N minus k minus 1 squared is what?
Oh, okay. Oh,
N
right,
squared
okay.
times this. This squared
Yeah.
times this k minus 1 minus 2n times this, which will be minus 2, right? Now you can understand the formulas that the problem says sum of cubed and sum of squared can be useful here, right?
Yeah.
So now calculate this. Do you know 1 squared, 2 squared to n squared is what?
Didn't we already do that?
Yes, it is what?
It's n times n plus 1 times 2n plus 1 all over 6.
Yes, and next one is what? This one.
No, I didn't get to read that one.
It is exactly like 1 to n, but you should square it. Okay?
Okay.
Now use these two things and solve this one. And let me... Okay. Calculate this, and when you calculate, you should check. For n, for example, for n3, the answer was 6, right?
Yeah.
For n3, the answer was 6. For n2, the answer was 1, okay? So try to calculate this, and at the end, check these two cases, okay?
Okay.
Yeah, could you give me a hint on this, please?
Okay, sure.
I'm just supposed to continue breaking the squares down.
Let's calculate. Do you agree the first one is n plus 1 to n minus 1?
Yeah,
Next one is what? Is 1 cubed, 2 cubed to n minus 1 cubed, right?
yeah,
And last one is minus 2n, 1 squared, 2 squared to n minus 1 squared. Agreed?
yeah.
Okay, so let's calculate. The first one is what?
N squared times 1, n minus 1 times n over 2.
Exactly. Next one is what?
Um, n minus 1 squared times n over 4.
Yes. This is squared over. Last one is what?
Minus 2nk times k minus 1.
K, we don't have any k. K is the
Oh,
variable.
yes, sorry, I calculated as k.
You cannot calculate in terms of k because k is only a variable of this. Means k from 2 to n. Okay, result shouldn't be related to k, right?
Yeah.
Okay, you
Yeah.
can write it 1 squared to n minus 1 squared, so it will be what?
So it will be 2n squared times n minus 1 times 2n minus 1
Over 6, right?
over 6.
Exactly. Now you should simplify this. Want me to tell you it's what or want to calculate on your own?
No, I think I got that
Oh, okay.
on my own.
Okay, I got n squared times n minus 1
Times 17
X.
n minus 7.
You said x?
No, I said n.
N. Okay, can you tell me it is what? N squared?
N squared times n minus 1 times 17 n minus 7 all over 12.
So let's check.
Just 17 then minus 7.
Directly for 1, it doesn't work. For 1, it's 0, sorry. For 2,
Yeah.
it is 4. 34 minus 7 is 27 over 12, right? It is not integer also. For
It
2,
is. It's
34
not.
minus
Oh,
47 minus, let me check. 37 minus 7 is 27. It doesn't work. Sorry. Why? I can't say this. But it will be 9, right? And 2 is 1,
yeah.
but it's 9. Okay. So let's calculate together to see what's the problem. So here, do you agree we can calculate, we can factor from n squared times n minus 1, right? And from denominator also we can subtract
Yeah,
12.
yeah.
Exactly the thing you did here. So because here we have 6 n squared n minus 1, it's 6n, right?
Yeah.
N squared n minus 1, we have n minus 1, 3n minus 1, right?
Yep.
Oh, here 3, okay. So 3, we should multiply this by 4. Minus 4 times this, which is minus 8 and plus 4, right?
Plus 4. Should be minus.
Minus 8.
Oh, wait, no, there is a minus. Oh, okay, that's why they're
Minus 3, yes. Minus 3 plus 4 is 1. Right? So it's n squared times n squared minus 1 over 12, right?
Yeah.
So for n1 it is 0, that's correct. For n2 it is 4 times 3 over 12, it's 1, it works, right? Let's check n3.
Yeah.
For n3 it is 9 times 8 over 12. So you can cancel 4 here, 2, 3 here, 3, 6. It's correct, right?
Yeah.
So our answer is this. So let me tell you, as you said, for